Question we've got here is all about wave equations. So equations that involve sine and cos, how we can rewrite them in the form k sine of x plus alpha, k sine x minus alpha, or k cos of x plus or minus alpha, given whatever form we're after, and then using this to further go on and solve it. Now, one thing we need to bear in mind is when we are solving trig equations, if we have a combination of sines and causes and even tans, what we have to be able to do is write the whole thing in terms of one of the trig equations, and then we can solve it. Now, this technique here helps us to do that by using the formula that we've got. So I'm first going to try and express it in the form k sine of x plus alpha. Then I'm going to take that and I'm going to use it, and I'm going to look at maximum values, and I'm going to look at solving equations using this. So the important part is that we start with part A. So express 7 cos x minus 3 sin x in the form k sine of x plus alpha. So first thing to do is write out our function and write out what expansion we're going to use. So remember the expansion for k sine of x plus alpha. Good thing, it's in the formula list at the start of the paper, so if you have a brain fart and forget, you can go back and take a peek. But in this case, it's k sine x cos alpha plus k cos x sine alpha. What we then want to do is start to look at the two parts of the equation and equate bits up so that we can then start to eliminate the alpha and the k, and we can get constant values so that we can put them back into the original function and then be able to solve it from there. So what I'm going to do to start with is I'm going to equate the coefficients of sine x and cos x. Now if I look at cos x here and the cos x here, if I imagine ignoring those parts there, the bits that are left are the equivalent of one another. So what's left is I've got k sine alpha here, and what's left here is 7, so I know then that k sine alpha is equal to 7. I can do the same thing for the other term. I've got sine x here and a sine x here, so again, imagine ignoring them. What's left is I've got k cos alpha, and that's going to be the equivalent of what's left here. Now, one thing you need to make sure you bear in mind is the sign is vital and important here. So it's not just 3 that we take over, it's actually minus 3. So I'll get k sine alpha equals 7 and k cos alpha equals negative 3. Now, what I've got here is I've got two different trig functions. If I imagine doing the CAS diagram and I'm imagining solving the both of them, and imagine I solve each of them individually. If I were to solve sine alpha, what I would do is I'd look at it and say, right, they're positive, so for the sine alpha, I'm going to get a solution in one of those two sections there. But if I were to look at the cos alpha and solve it on its own, I'd actually get two solutions, one of them in the t, one of them in the s. So I've actually got various solutions for them. What I want to do is find a solution that works for all of the trig functions we have. So in order to do that, what I actually also have to now construct is a relationship for tan alpha. Now we remember that tan is sine over cos. So in this case, tan alpha is the k sine alpha over k cos alpha, which in this case is negative 7 over 3. So if I then go back to looking at the CAS diagram with that, where tan is negative, that would give me a solution in C, but also a solution in S. So if I want one answer for alpha that satisfies all three trig equations that exist, I have to find the solution that's in this section here and use that for my value for alpha. So what I'm going to do is I'm going to solve the tan. Now if I solve tan, what I'm able to say is that alpha is equal to tan minus 1 of negative 7 over 3. Now if I solve that, what I'll end up getting is that alpha is equal to 113.19 or 0.2. Let's just round it to one decimal place and go to 0.2. So that's the value of alpha I'm going to get. If I solve all three of them, that's the one common value all three of them will have. So it works for all three trig equations, so we're going to use that for alpha. So I've got one part of the function here, the A, I want the k now. Well, if I remember that sine squared plus cos squared is equal to 1, I can build a relationship for it where I know that k is then going to be equal to the square root of the k sine alpha squared plus the k cos alpha squared. So in this case, 7 squared plus negative 3 squared. So in this case, I get that k is equal to root 58. So what I can now do is go back and rewrite the whole equation and say, fine, so 7 cos x minus 3 sine x can now be written using the format k sine of x plus alpha as root 58 sine of x plus 113.2. So there you go. I've taken the equation that had sine and a cos in it, and I've rewritten it as just a sine. So what I'm able to do is, when required, solve it. Now if we go into part B, first part it says, hence or otherwise, find firstly the maximum value, and then a value for x where it occurs. Now, it wants the maximum value of 14 cos x minus 6 sine x. So it wants the maximum value, so B part 1, of 14 cos x minus 6 sine x. Now what you'll notice is if I take out a common factor of 2, that's 2 times 7 cos x minus 3 sine x, which was the original function, but I now know that is root 58 sine of x plus 113.2. So it's then the equivalent of 2 times root 58 times sine of x plus 113.2. Now we know the maximum value of sine is equal to 1. So the maximum value here is now going to be the 2 root 58 times the maximum value of sine. So 2 root 58 times 1. So I can then say is therefore the maximum is equal to 2 root 58. Now the second part wants find the value for x where this occurs. Now we know the maximum value for sine occurs at 1. We also know that that occurs at 90 degrees. So what it means then is that for the maximum to occur, this 2 root 58 sine of x plus 113.2 is going to equal the 2 root 58, which is the equivalent of me saying sine of x plus 113.2 is equal to 1. Because I'm just eliminating the other two by taking them as a common factor. So what this allows me to say then is that x plus 113.2 is equal to sine minus 1 of 1. Well, we know that that's going to be 90. So if I then solve that, what I get is x is equal to 90, take away 113.2. That then gives me an answer of negative 23.2 degrees. Now I would say that's good, however the issue is that that falls outside the range that I'm given here of 0 to 360 degrees. So I've now got to bring it back in to the range that we are after. Well, in order to do that, all I'm going to do is I'm going to add on 360 degrees. Because the period of the curve is 360 degrees, if I add it on, what I end up getting is that x is equal to negative 23.2 plus the 360 degrees. So x is equal to 336.8 degrees. And that there is where the maximum value will occur. Now I can find that by substituting it into either the 2 root 58 sine of x plus 113.2 or even going back to my original equation and substituting it into there. I'll find the correct solution for either of those regardless of what I do. Now that is a lot thrown at you in one question, and it's a lot in terms of trig stuff, and it looks quite complex and complicated. However, when it comes to a question like this, particularly part A, there are a set of steps that if you follow them through, you will get the marks every single time. The reason being, there's a couple of parts of the questions where it states this must be written explicitly to get the mark. So if you write those parts explicitly, you will get the mark. Your first mark comes from writing the correct expansion here of the k sine of x plus alpha. Now the mark scheme will state the k sine x cos alpha plus k cos x sine alpha is mark 1 if it's stated explicitly. So even just by writing that expansion down, which you can read from the start of the paper, you get 1 mark. Your second mark comes from writing down the k sine alpha equals 7k cos alpha equals negative 3. And again, that states that it must be written explicitly. So you get the second mark for that. If you don't write those two down, but you still go through and get the correct answer, your root 58 sine of x plus 113.2, you'll actually lose those 2 marks because you've not written them down. Seems crazy and it's insane to think, but that's the way it works. Your third mark comes from finding k, so getting your root 58. Your fourth mark comes from getting the value of alpha and writing this bit here down as well. You have to write it down because it says express it in that form. So if you don't write it in the form, despite finding k and alpha correctly, you won't get that final mark. For part B, part 1, you get 1 mark here. Yeah, finding that 2 root 58 is equal to the maximum. And then in part 2, you'll get 1 mark for getting to this stage here, that x plus 113.2 is 90. And then you get your final mark for getting the correct solution by bringing it back into the range of 0 to 360 degrees where we're working. So this question here, 7 marks it's worth. Remember, there's a couple there that you can get as standard, even if you forget the maths or you mess up the maths somewhere, that you can get just by writing things down explicitly. Bear that in mind, and please don't forget that when you do this type of question. Then it's working it through and remembering the properties of trig functions, i.e. the maximum of sine is 1, when the maximum occurs at 90 degrees, and working it through from there. Remember all of these facts. Again, looks overwhelming. It's not when you break it down and when you start to look at the simple skills that are involved. Break it down, take your time, show your working and write it out, and what you'll find is as you do that, it actually becomes more straightforward, and eventually you'll hopefully find it easy peasy, lemon squeezy.